Good day. Today we're going to be doing tangent to a curve at a point on the curve. To find the gradient of the curve, first find the gradient of the given function, alright? And remember, when you find the gradient of the given function, that's when you're actually finding the gradient of the tangent to the curve. Now, once you've found the equation of the tangent to the curve, all you have to do is to substitute the x-coordinate of the given point into the first derivative to find the value of the gradient, right? Remember, when you find the gradient equation, that is just an equation. For you to find the actual gradient, you need to substitute the x value at that specific point so that you can find the value of the gradient at that specific point, okay? Once you have the gradient, use the straight line formula to find the equation of the tangent. So basically, you all know the straight line formula where you have y minus y1 is equals to m. M is the gradient that we found in step number 2, and you'll have x minus x1. Note that y1 and x1 is simply the coordinates of the point that lies on the straight line, okay? This point doesn't just lie on the straight line, it lies on the straight line at the same time it lies on the curve. So basically, the curve and the tangent line will share this point. They meet at that point, they intersect at this point, so they will share this point, okay? And we simply need to find a gradient at this point. For you to find the gradient at this point, you just have to find the gradient equation using the original function or the original curve, and then you substitute x value into that gradient equation to find the gradient of the tangent at that specific point. Everything will make sense in a moment. Guys, please note that these two are very important in us finding the equation of the tangent to the curve. Please highlight them and make sure that you write them somewhere because they're very important, as well as the point after the formulas, after the equations. This point here where x1 and y1 are the coordinates of the point that lies on this straight line. Please highlight that because it's also very important. Let's do examples. Find the equation of the tangent to the curve at the given value of x. So basically, this is the equation of the function we are given, but we're trying to find the equation of the tangent when x is equals to 0. Okay, please note that for me to find the equation here, the first thing that I need to do is to find the gradient of the tangent by simply finding the derivative, okay, the derivative of the given function. To find the derivative, all I did was I took this exponent 2 and I multiplied it by the coefficient that I'm differentiating with respect to, in this case the coefficient of x squared. And from 2 I minused 1. Similarly with x, the exponent of x is 1, so I took this 1 and I multiplied it with the coefficient of x, which is 1, and I minused 1 from that exponent. The derivative of the constant 6 is 0, okay? Hence, I have 2x minus 1 as my derivative. Now, for me to find the gradient at a point where there's x, I'm going to substitute the x coordinate of the point into this first derivative, into the first derivative. And when I substitute 0, this is what I'm going to get, meaning that the gradient of the tangent to the point is -1. I only have the x-coordinate of this point. So for me to find the y-coordinate of the point, I'm going to take the given x value and substitute it into this original equation. So where there's x, So where there's x, I'm going to substitute 0. Substitute this given x value into the original equation for you to get the y value. And the y value is -6. So basically, the y coordinate of this x value will be -6. So I will write it as a coordinate. Then substitute this into the straight line formula. Where there's y1, I'm going to substitute -6. Where there's m, I'm going to substitute -1. And where there's x1, I'm going to substitute 0. And this is what I'm going to get. Please note that -6 is in brackets because it's negative. Simplify that, you will get this. Transpose 6 and simply make y the subject of the formula. And this is the gradient. This is the equation of the tangent to the graph at x is equal to 0. Let's do the second example. Find the equation of the tangent to the curve at the given value of x. Firstly, I'm going to find the first derivative. Two times -3 is -6, and from 2 I'm going to -1. 2 times 1 is 2, and from that one I'm going to -1, so basically I'll be left with 2. So my derivative will be 6x plus 2. Then I'm going to take the given x value and substitute it into the gradient formula, and it'll give me the gradient of the tangent at x is equals to 1, which is -4. I do have the x coordinate, I'm missing the y coordinate. How do I find the y coordinate again? You will take the given x coordinate and substitute it into the original function, and this is what you will get. So wherever there's 1 in the original function, you will substitute, wherever there's x in the original function, you will substitute 1, and that will give you 0. So your coordinates will be 1 and 0. x1 is 1, y1 is 0, and the gradient is -4. Do that substitution, and when you multiply out here, you will have -4x plus 4, and this will be the equation of the tangent to the graph at x is equals to 1. The third example, I have this. I will simply start by finding the first derivative. 3 times 1 is 3. From 3 you -1, hence you have 2. 1 times 4 is -4, and then from 1 you -1, it will be x to the exponent of 0. So x to the exponent of 0 is 1, but we don't write it. The derivative of a constant, in this case 2 is your constant, is 0. So I don't even need to write that. This is the equation of the gradient of the tangent to the graph or to the curve. And this is what you will find as the gradient. Your gradient will simply be 8. You do have the x coordinate, you're missing the y coordinate. How do I find the y coordinate? You will take this x coordinate and substitute it into the original equation. It will give you the y coordinate, which is equal to 2. Write the straight line formula. You do have y1 is 2, m is 8, and x1 is 2. Substitute into the straight line formula. This is what you're going to get. Multiply out, that's what you will get when you break the brackets. 8 times x will be 8x. 8 times minus 2 will be minus 16. Make y the subject of the formula by transposing that negative 2 to the right hand side. It will be positive. So on the right hand side, you will have 8x minus 16 plus 2. Minus 16 plus 2 will give you minus 14. And this is the equation of the tangent to the graph at x is equals to 1. The fourth example. Find the equation here. You're going to take the original equation, the original function, find the first derivative. 3 times minus 2 is minus 6. From 3 you minus 1, you will get 2. 2 times 6 is 12, and from that 2 you minus 1, you will get 12x. The derivative of a constant is 0, so the derivative of 4 will be 0. Now take 1, the given x value, minus 1, and substitute it into the first derivative, which is the gradient of the tangent. It'll give you the gradient of the tangent, which is m, and that will be equal to 6. We do have the x value, which is negative 1. We are left with the y value. To find the y value, take that x value and substitute it into the original function. And this is what you will get. Simplify this, you will get 0. You do have x1, which is negative 1, and y1 is 0. You do have the gradient, which is 6. So where there's m, you're going to substitute that 6. y1 is 0, x1 is minus 1. Please note that because x1 is minus 1, I've put it in brackets. Negative multiplied by negative is positive. This is what you're going to have. Distribute the 6 into the bracket. 6 minus x will give you 6x. 6 minus 1 will give you 6. And hence you have y is equals to 6x plus 6. And this is the equation of the tangent to the graph at x is equals to negative 1. Find the value of x for which the tangent to the curve will be parallel to 6x plus 6. So in this case, please note that we are not calculating the gradient. We are simply trying to find the x value. That will result in us having that tangent line. Trying to find the coordinates of the point that resulted in us finding the equation of the tangent line as well as finding the gradient. There are only two things that link these two equations. We need the derivative of that equation to find this 6. Remember, 6 is the gradient. Or you can simply equate these two equations to find the points of intersection. But there's 3 over there, and that 3 will make life a little bit difficult for you. So the only option we have, the easiest option we have, is to find the gradient of the original function. And this is the gradient of the original function. That times that will give you minus 6. You minus 1 from 3, you're going to be left with 2. 2 times 6 is 12, and from 2 you minus 1, you'll be left with x, the exponent of 1. But you are given m. M is simply the gradient of the tangent, because this line, they told you that the tangent is actually parallel to this line. Okay, so basically the tangent and this line, they share the same gradient. So we can assume that the gradient of the tangent will also be equal to 6. So hence we have the gradient of the tangent is equal to 6. So m is equals to 6. So where there's m, I'm going to substitute that 6 and try to find my x value. I will have a trinomial that I need to factorize, and my x value will be equal to minus 1. Please note that I'm going to repeat what I've just said. The gradient of the tangent will be 6. because the tangent and this line are parallel. Remember, when lines are parallel, they'll have equal gradients. Okay, so the gradient of the tangent will also be equal to 6. Remember, 6 is simply your gradient, which is the coefficient of x. So 6 is actually your m when we look at the straight line equation. So basically, this function and the equation of the tangent, of which we don't have, they do share one thing. They do share an x value, which is -1. And that is what we are simply looking for. Find the value of x for which the tangent to the graph is what is perpendicular to this line. So we need to first find the gradient of the tangent. Now we know that for us to find the gradient of the tangent, we need to find the derivative of the given function. 2 times 3 is -6, and then you minus 1 from 2, you'll be left with 1. 1 times 2 is 2, and from that 1 you minus 1, you'll have x to the exponent of 0, which is just 1, and you don't write it. So this is how we find the gradient of the tangent. But we are given that this gradient, to find this gradient, or m of the tangent, when you multiply m of the tangent with m of this line, which is 1 over 4, they should give you -1 because the gradient of the tangent, the tangent and this line, which is given, this straight line, which is given to you, they are perpendicular. So when you multiply the gradient of the tangent with the gradient of this line, they should give you -1. And then I'm going to solve for m. M in this case will be -4. So basically, I've just found the gradient of the tangent. So I'm going to go back to my gradient formula. And where there's m, I'm going to substitute this m, which is -4, and this -4 is simply the gradient of the tangent. Where there's m, I'm going to substitute -4. So basically, -4 will be equal to 6 minus 6x plus 2. And then you just solve for x, transpose this to the left-hand side. You will have -4 minus 2. On the right-hand side, you'll be left with -6x. On the left, you're going to have -6x. On the right, you're going to have -6x. Divide by -6, you will get x is equals to 1. Basically, the tangent and the given function, they share the same x value, and that x value is 1. So basically, they intersect at this x value. They meet at that x value. Find the values of k for which the tangent to the function that will be equal to that. Okay, so we are given the equation of the tangent. This is the equation of the tangent because they said the equation of the tangent, find the values of k for which the tangent to the curve is equal to that. So this is the equation of the tangent. Okay, so we need to find k. So what is the relationship between this given function and the tangent? They do share the same x value and they do share the same y value. And for me to find out which x value they share, I'm going to find the derivative of that, because the derivative of the original function will give me the gradient formula, which will allow me to find the gradient of the tangent, which is -9. So I will simply find the derivative of the given function, which is -3x squared plus 3. You should be able to know how to get that by now. I know that this equation will be equal to 9 because we are given the gradient. All I'm going to do is to solve for x, hence x here will be equal to plus or minus 2. So basically, once I have plus or minus 2, once I've found the values of x, I'm going to take this x value. I'm going to start with +2 because we have two solutions there. X is equals to 2 and x is equals to -2. I'm going to start with +2, substitute it into the original function, which is x minus x cubed plus 3x minus 1. It will give me the y value, and my y value will be -3. Now my coordinates will be +2 and -3. this original function and the equation of the gradient. The original function and the equation of the gradient, they share one thing. They meet at this point. They intersect at this point, which is 2 and minus 3, where the x value is 2 and the y value is minus 3. That's where they intersect. They have that point in common. I'm going to take this point and substitute it there. Where there's y, I'm going to substitute minus 3. Where there's x, I'm going to substitute 2. And this is what I will get. All I have to do is to multiply this 2. Negative 9 times 2 will be minus 18. Transpose minus 18 to the left-hand side. It will be positive 18. So k is equals to minus 3 plus 18, and minus 3 plus 18 is 15. This is the first k value. The second k value, I'm going to take the second x value, which is minus 2, substitute it into the original function. It'll give me my y value, which is positive 1. Now my coordinates will be minus 2 and 1. I'm going to take this minus 2 and 1 and substitute it into the equation of my tangent, and I will get that. Where there's x, I substituted minus 2. Where there's y, I substituted positive 1. Now solve for k. This is what I'm going to have. So 1 minus 18, as I transpose 18 to the left-hand side, is going to be negative. On the right-hand side, I'm left with k. So k is minus 17. It's time for you guys to work. Next, we're going to be doing cubic functions, how to draw cubic functions without using a calculator.